In the Digital Science Speaker Series, we don't just look to the future of research, we look at the history and the philosophy of science as well, and what we can learn from it. And on that note, I'm joined by two amazing speakers here at the Max Planck Institute today, Maria Avxentevskaya and Ben Johnson. Thank you so much for joining us today. Maria, Ben, welcome to the DS Speaker Series. I'm going to start with some very tricky questions because you both have quite prolific careers already. It's probably the hardest question. Can you tell me who you are, what you're all about, what your background is, and what brings you here to the lovely Max Planck Institute? Maria, shall we start with you?
Thank you. Sure. My name is Maria Avxentevskaya. I also go by the name Avxent. I use it for publications. And I have been at the Max Planck Institute for History of Science for 7 years now, since 2016. I joined it as a postdoctoral fellow in Department 2, led by Bailey Dustin. Spent 3 amazing years there, and then moved on to the group, research group entitled Experience in the Premodern Sciences of Soul and Body, led by Katja Krause, and this is where I am at the moment. And before that, I had a background in linguistics and translation studies and philosophy, and primarily early modern history of culture, and hence my specialization in essentially early modern history of science. But I'm trying to see it like many other people who do early modern science, including Rainy Dustin herself. I would dare to say that I try to look at early modern science as something that is just early but already modern. And that's the lesson we can take from that period for understanding what is happening with us right now, what is happening with science, which has changed its role tremendously since that time. And in a way, as many people say, has become something of our own modern day religion in certain ways, shaping our beliefs, shaping our norms of discourse. And that's my take on that. That's what brought me here. This is a glorious institution. I'm really patriotic about Max Planck Institute History of Science, and really happy to be here and immensely grateful for this opportunity to talk to you. Thank you.
Oh gosh, no, the pleasure is all ours. Thank you, Maria. There's so many things you've already said that I cannot wait to revisit. But first off, Ben, can you introduce yourself and tell us what brings you here?
To the Max Planck Library. My name is Ben Johnson. My publishing name is Benjamin Johnson. I'm a physicist, so I originally started doing work in the laboratory on solar cells, and I got my PhD doing that. Then I moved around to Postdoctoral Institute. That was sort of I did a postdoc there. I worked in the lab there for several years. How did I get to... I found a library when I was doing my master's degree in Wannsee, which is down towards Potsdam. And I found this book called The Electron, which I think is by Millikan. And it just had all this history of the electron. And at that point, I thought, it's an electron, right? It's just so simple. But the whole history of how we came to understand what that is, that it exists, and all these different forms of understanding what the electron is really got me back then. So the history of science was always sort of this peripheral thing while I was doing my research that had always interested me. And then it was just in search when I was working at Postdoctoral Institute. I put in History of Science Berlin, and I saw, this thing's right around the corner. It was, that was just happenstance. And I came over and I started to talk to some people, and slowly I got more involved in some of the activities here. The 2 directors, the one that I worked for here and the one there, knew each other and wanted to have a collaboration, and at some point, and so I jumped on the opportunity when I got it. They offered me to write the book on ammonia that I wrote, and it wasn't really clear what was going to happen, but I just had, the topic was ammonia, and I could do basically whatever I wanted, and that was the move over from laboratory research. And then, I don't know, I guess I just continued to develop this idea, this perspective I have on what science is and how we're supposed to practice science. The history of science obviously taught me a lot, but then that gets into science communication, the other stuff that I just keep on wanting that new challenge about trying to see, I guess, how far I can get with the ideas. And my ideas haven't stayed with laboratory research or the history of science. They just keep on. So that's one. And that's why we met as well, because of that extension of those things that I'm thinking about.
That's brilliant. I love that aspect of really keen collaboration as well. Because I think we have seen that in the past, in the history of science. There are so many stories that we can pick out, that we can tell, that are still so relevant today. It reminds me a bit of, is that book, Cycles of Time? I think it's by Roger Penrose, but it's these things, these repeating kind of incidences. Can you reflect on any aspects of the history of science that you've covered that is still so relevant today that we need to make sure we continue to learn from, that we don't forget? That's a massive question.
So you wanna feel it down? Or?
It is a massive question, and part of its massiveness is because there are really many things that can be mentioned. I'm just trying to think of some really exemplary. For instance, I would say perhaps the role of scientific institutions in shaping the practices of science. This is something that we have mentioned just a few minutes ago when we were chatting around those beautiful bookshelves, talking about how some practices of science were set a long time ago, and they still shape the norms of how science needs to be done. And science, especially certain branches of it, and by science, I think it would be good to mention to cover also medicine, medicine as a scientific discipline. And some of scientific disciplines really need to be conservative in terms of their practices, because the margin of error, the price of error is too high in medicine. The price of error is life and death. And that's one of the reasons why the scientific method keeps going the way it was set up, through logic, through experimental protocols, through publications of results, reproducing experiments and publishing the results. All of that was set up 300-400 years ago. And if we understand how it was working initially, if we understand how it was set up, what was the mechanism, what are the reasons why it had to be like that, we understand a little bit, I think, why we stick to that, why we have to utilize those instruments, even though our technologies have changed tremendously. Yeah, well, that's one point that comes to my mind right away, but Ben probably would have more insight.
I mean, I could talk you mentioned the cycles. That's something that's been really important to me in science history, especially today, because there's a lot of discussion about how complicated the world is right now. And that is something that appears to us to be the case through history again and again, and sometimes it doesn't. So around 1900, there's also the world electrification was coming in. There was new quantum mechanics on the horizon. There's a lot of crises in knowledge, and people are having a difficult time getting their head around it. And then, then there was times like in the 50s where nuclear power was just kind of a utopian thing, and it didn't seem as complicated. It seemed like things were going in the right direction. So these cycles of complexity somehow get encapsulated and then accepted as a building block of what we can do. Mm-hmm. And then the new complexity builds up around that. And that cycle keeps on going, it seems. So we have these waves of being maybe or feeling like we're not so able to understand the world, and then times when we actually feel like we have a handle on it. And then looking at it through history, you see that complexity just branches out everywhere. And then there's no end to it, I guess, as a single person trying to research that.
So what can we maybe learn from that? Let's say, for example, we're currently in this age of artificial intelligence. It's the zeitgeist word. Everybody is talking about it, not just researchers, but people across different public groups. Generative AI. The fear that AI is going to take our jobs, take over the world, take over everything, and we're just going to be these mere mortals that just can't cope with it. What can we learn about, electrification, how that was handled, how that was eventually adopted, how we worked maybe with the public? Was there a need for greater public engagement to take people on the journey? What can we learn from that you think maybe we can be adopting now?
You want to go? Or?
Yeah, I could say maybe I could. It's a very really interesting discussion. Maybe we would need a couple of goes each of us to really cover it. If that's okay for the format. So one point that I just discussed with my students last week, talking about coincidentally we had a session devoted to science communication and artificial intelligence last week, so it's kind of fresh in my memory, and one of the students said that yeah, so there's this fear, and I share it. She said that we have this new technology, and now the natural intelligence is going to be out of demand because artificial intelligence is going to take over. And it's not only about jobs, it's also about mental capacities and what it means to be a human. Because for thousands of years, literally, what it means to be human meant to have a certain knowledge of things. It's about knowing, it's about memory, it's about being able to practice certain cognitive skills primarily. What does it mean to be human if there's something that practices cognitive skills times better than me? What I do with that? And it was a valid question. And what I had to respond is that this is what's really curious is that this discussion is literally thousands of years old itself. Because if you look at the conversation between Socrates in Platonic dialogues, that's what that civilization was going through at that point. It was transferring from speech, oral speech, and memorizing all spoken words into writing words down. And there was exactly the same, not exactly the same, but similar in principle kind of concern, saying, what does it mean to be a human? It meant to be human to be able to memorize, to keep in memory, to process in your mind everything that has been said to you. If everything is written down, this written word goes God knows where, everyone can read it, no comments, who knows how it will be understood, interpreted, and whatnot. What does it mean to have knowledge? And what is knowledge? And so that famous conversation 2,500 years ago took place. And there have been different stages in between, certainly, when similar questions were asked. And so my point would be, first of all, this is not the first time we've grappled with this. Second, there have been cases, we can learn from that. And that's probably one of the reasons why we need to study history of science, because it gives us an agency in understanding these problems and an agency in solving them somehow, in having a choice on how to go about them. Like in your personal life, if you remember yourself and you remember how you responded to certain challenges, you have a choice of options. And it's a way to know yourself for the humanity, for knowledge, or people having knowledge to understand how to deal with these problems. So I'm taking too long.
No, it's amazing.
No, I mean, the last thing you said is also one of the things that concerns me the most about new technologies is not always the technology itself, but the way that people use the technology in a not so thought through way a lot of times. So with AI, I can also imagine that some of the dangers are going to not be the technology itself, but the capabilities of the technology that we're maybe not aware of. At the same time, I've also been watching my share of interviews on that, and there are public figures, leaders of the tech companies that stand to benefit a lot from the institution of AI, who are also at the same time warning against it. So that also makes me, a bit cautious. I mean, there are obviously some dangers that some people that know what they're talking about are worried about. So I think that's definitely something to be aware of. As far as creativity goes, most of what I've seen from the AI is based on big data combing, whether it's making I don't know, some Rolling Stones song sung with Kurt Cobain's voice or whatever it is, or some newscaster, write me a opening to this news bit with, in the style of whoever. All that's based on stuff that's already out there. And so, I mean, humans are still good at coming up with stuff that doesn't exist yet. And I don't know whether AI can do that, but if the algorithms are based on combing big data in the internet and data mines, I don't see that happening right now. Be interesting. I don't know. That's not my area of expertise, but I don't know whether AI could come up with a new music movement like grunge happened in the 90s. I mean, there's so many mistakes. There's so much subjectivity there about what's good and what's not. On the other hand, as far as music goes, it kind of seems like maybe humans have invented enough music that this AI can just keep on regurgitating it in ways that we think is interesting. I don't know, but I definitely see an opening there for this like accidental human creativity that will keep making us important as far as making progress goes.
And in a lot of ways, I think the things that become popular have become popular almost through that scientific method. Lots of things are put out there, and some things work, and lots of things don't. And it's that iterative,
For a lot of reasons.
to success. Yeah.
For a lot of specific reasons at that point in time that existed.
Yeah. Fascinating. We are here in the Max Planck Institute's beautiful library. This place has quite a history, sometimes challenging, often very productive. It does make me think about ethics and the ethics of scientific research, the scientific method, the way that we involve everybody that will be impacted by that research in that conversation. Can you tell me maybe a little bit from the perspective of the history of science, what we can learn about ethics and maybe moments we haven't been as considerate as we should have been and what we've learned from that, and perhaps the role that science communication and public engagement can play in helping us navigate that ethical path so that science can truly benefit as many people as possible?
Thank you. This is a huge, it's
no pressure.
question. Yeah.
Why don't you narrow that down for me and you go first?
Yeah,
Try to
thank
just
you.
clean up.
Yeah, thank you. Thank you very much. Responsible role. It's really a huge question, and also again, teaching science communication, I am amazed every time. So one of the topics that I take in my course with students is we talk about modern day scientific controversies and how they are discussed in public, so that they get a little bit more of a picture of what is actually hot in science and how to talk about that. What's the ethical way to talk about it? And it's amazing how very swiftly the conversation abandons those matters of purely scientific or medical or biochemical details and goes into matters that are ethical, which are kind of basic human questions, but if you try to put them into some kind of discipline, that would be ethics, most essentially, such as CRISPR, gene editing, something like that. What's going on with it, how we should perceive that. And indeed, many such questions and many such issues have taken place, were there in the history of science, and they can be considered. For instance, perhaps again, being a modernist, I always tend to look into that 17th century horizon. And for instance, at that point, the issues of that the new science grappled with, this was really the time when people saw themselves as living in a new world, new technologies. They loved this expression, nova reperta, new inventions. It sounds familiar, right? A little bit like from modern day. And what the issues they had with these new inventions and new technologies were that, for instance, it challenged the position of a human being in relation to God. And it was not only a matter of just Christian belief, like I believe in God, I don't believe in God. Religion was giving you the whole doctrine of the whole ethical structure of life, what's good, what's bad, what are the good acts, what bad acts. If you have done something bad, how do you reconcile with that? What are the ways of reconciling with other people about it? And so on. So also in communities. And at that point, this question about how to deal with technologies, the new world, the new powers, the new political developments, the empires, the new weapons that were invented, it was also tackled by philosophers such as, for instance, Francis Bacon, this founding father of scientific method. He was, for instance, very conscious of this kind of exhaustive, aggressive, exploitative attitude to nature. And for instance, in many of his treatises, one of them is Valerius Terminus, he was talking about how it is really important to maintain a certain balance of understanding nature not only as a possession, but also as a gift. And that point, it would be divine gift. Yeah, the nature was created by God, so it's divine nature at that point. but not only as a possession, but also as a gift, and how important it is to remember that this attitude, this processing and operational operational thrust of scientific method, how it needs to not lose the sight of the ethical values and not lose the sight of the benefit of society. Bacon was essentially one of those first people who really put this goal, set up this goal that science is for the benefit of mankind. And in his wonderful narrative of New Atlantis, he tried to picture this ideal society with all its social, ethical values as he saw them. So that's, for instance, one of the lessons I think we can learn. And again, the differences are vast between 17th century and now, but we can learn from the response, from the way of responding to problems, and have, again, a choice now of what has been done right and wrong in the past and how we want to proceed.
Yeah, ethics.
Ethics.
And science communication and public engagement, because it plays such a fundamental role in that.
Yeah. I mean, there's ethics, I think, from the different kinds of research are then can become very specific questions. The use of living creatures in some kinds of medical tests, that's not something that I think I have a good level of knowledge on to be able to say anything about. That is a hot topic. That's something that's going on right now that definitely needs to be debated. For what I've been, and I mean, I say that as a preface because what I would like to say is quite specific to my physics background and chemistry. And I wrote a book on ammonia synthesis and ammonia in the last century, ammonia and the atomic bomb or atomic energy are basically the two best examples of the double-edged sword of science. Ammonia is used to make fertilizer. It can also be used to make explosives. The same methods were also used to make poison gas. So you have, that discovery saved a lot of lives, also caused a lot of destruction. I don't think I need to go into the atom. That's, obvious what's happened there as well. And I'll come back to the same thing I said about the AI, about the user being informed. I mean, science establishes or discovers knowledge. That's what it does. Doesn't attach any. I was going to say value, but that's not what I meant. It doesn't attach any roadmap about how to use that knowledge, and that's then up to us. And it's obvious with, countless examples that the knowledge and the information you gain through doing research you can use for, good or destruction, whatever you want to do. And there's a lot of commentary about, maybe we should limit the bad side. I don't see how that happens. That's up to us, and that's our responsibility to be able to deal with that. And I feel like moving towards limiting knowledge production or trying to limit this bad side that can come out is just inherently anti-science. That's not something that can happen. The establishment of that knowledge is basically a neutral thing, and then the next step is what we do with it. There, we can make some inroads. There is where science communication comes in, trying to get people to be aware of the new knowledge, information, of the new technology, teach them about that. I also don't like that word teach. It's a two-way street, the science communication thing, but engage with them about how their choices can lead to certain outcomes. So, and I think that's just this ability to establish or uncover new knowledge is something we have to keep doing. And then we'll have to keep find other ways to, I guess, limit the repercussions.
Maybe a little comment here. Maybe you could go to have another go here. It's a huge question, really, really amazing. I would like to confirm, kind of, the statement requires confirmation, but just to give an example of how right that is, really. There's this famous statement by Einstein where he says precisely that science, and he knew too about science, science is something that has immense power, but science on its own cannot is not capable of devising the means and ways and purposes of exercising that power. And he was talking about it with some passion, because at that point he was involved in the dispute about the use of nuclear weapons and the building of nuclear weapons and so on, which his research contributed to. So science on its own cannot, through the nature of scientific method, also take care of the purposes of exercising that power. And this is where various humanitarian questions come into play. And how do we even figure out those humanitarian questions? How do we talk about them? That's science communication. That's exactly where the field which is immense and broad and diverse, which is exactly where the film gives a space to that discussion. And speaking of other ethical matters, one point, for instance, would be, that goes like a black thread through the whole of history of science, is what is science has been said and what is not. Pseudoscience. Many inventions and discoveries in the history of science, as we know, first emerged under the label of magic. We also just talked about a little bit before, looking at our institute's timeline or discoveries. Very often, first it would be labeled as magic, then it would be law of technology, and then sometimes there would be relapses into seeing something as a new discovery and even labeling it as magic, but actually it turns out that it's just pure fraud. And the topic of pseudoscience, oh goodness me, we have been witnesses to that over the past few years of the pandemic, when pseudoscience and science clashed on the topic of vaccination, which is a life and death topic, essentially, in many cases. So that's, for instance, the story that goes on and on for centuries. And here we are now talking about science, pseudoscience, about in terms of vaccination, and we can certainly learn lessons from history of how people dealt with pseudoscience before.
I wanted to pick up on that line of magic real quick. When I was talking about the cycles earlier, that's also a good way to put it. I mean, there's sort of this meme about showing, I don't know, Darwin a TV and he won't understand how it works, but it kind of is like that. I mean, these waves of getting a handle on complexity sort of take away that magic feeling from things that they had when they weren't understood so well. And there was some amount of just kind of going along with it because you can see it, so it obviously happens. And then science unravels that eventually, and will maybe take away some of the excitement. But that's also a necessity. That's what happens, and there will be other things around the corner that appear to us to be basically magic again, and we'll probably figure it out again.
Gosh, you both speak so eloquently. I could listen to you both speak for hours. All I could think was Peter Parker's Uncle Ben also said that, the thing that Einstein said. But, it persists because it's true with great power. I do find the ethics thing really interesting, and we talked about research culture before. I suppose in the history of science, a lot of things that were really quite terribly done have led to some very positive outcomes. As you said, I was thinking maybe of Henrietta Lacks and the HeLa cells that were taken without any consent, but we've learnt so much from that. I've been watching the second season of Good Omens recently, and there's body snatchers, really kind of doing all those really early physiological experiments to help us better understand disease and how to save people from disease and stuff. And so a lot of the way that we do scientific research now, for a long time, I think, was gently refined based on what we understood and what we knew at the time, and kept with the time. But I do wonder whether you can comment on whether you think we have continued to do that, or whether perhaps the way that we do research has become stagnant and perhaps dated, rooted in a time that is perhaps not appropriate for how we could do research now to best benefit all of society.
Thank you. It's you're okay. So we have an experimental protocol here developed. Yeah.
I love it. Science in action.
Science in action. Yeah. And it's a very massive, important, and difficult question. And as we said right before this conversation, if we don't talk it here, where are we going to talk about it? If not in such spaces, which are conversation free and open. And indeed, there has been a lot of discussion about how the new technologies, especially, we would say in new scholarly media, broadly speaking, have changed the research landscape, and how this has led to controversies and certain disbalances, discrepancies between, for instance, the ways of giving credit in science and the ways of publishing scientific results. At this the session yesterday, there was a very good talk joined about how the new ways of publishing, digital platforms, open science, open access tools, open access formats, how all of that changes the ways we configure scientific practices. And of course, now we are at the dawn of the AI, and the AI is going to shake it up big time for sure in the next maybe 5 to 10 years. So yes, that's right. Many things happen, and one of the tendencies and one of the things that I have noticed, perhaps Ben would disagree with me and discuss it further, is that it seems that first of all, new media invite more multimedia approach to dissemination of scientific information. Nowadays, when I started my teaching career at Bard University 7 years ago, I was only giving my students a scholarly paper as assignment. Now I'm giving them a paper and a video because there are a lot of very high quality video materials that multimedia materials they can very usefully process. And that's not only for teaching, that also goes for research. What happens with then our CVs, with giving credit, with the ways of how it is processed, assessed, how it is normalized, how it is assessed in terms of its quality and so on. Yeah, that's one question. And then another question seems to be that because of this multimedia avalanche we are having now, also with AI on the horizon, it begins to slightly reconfigure what is considered to be the standard for academic publications, such as a monograph. In the humanities, the monograph is your opus magnum. In the social sciences, in natural sciences, a monograph plays a different role. Yeah, let's put it this way.
Natural science, right? It's really, I mean, yeah, not
and
very useful in academic sense.
And so that's what we are probably going to figure out in the next 5 to 10 years, how to cope. And again, this is not the first time it happened. When the printing was invented, it was kind of similar. But I think it would be a good point to press the button to. Yeah.
I mean, you just touched on what I wanted how I wanted to respond to your question was that the differences between the disciplines is really comes out in a conversation like this. I mean, this is the second question you've asked about where you kind of touched on biology, and I suddenly just saw the limits to my own knowledge about that, because again, I think about this in terms of like a lot of technology, chemistry, physics, and these kinds of things which don't directly affect organisms, as in you take them in and you experiment on them, right? The outcome of energy technology will then have an effect on us. But then also what you said about the types of publications in the different disciplines, it's really just marked differences that are in the natural sciences in the lab. You know, maybe someone a little bit advanced in their career would think about doing some kind of review book about some technical theme, but it's not your key to the rest of your career like it would be in the humanities. I also think a lot about in the humanities. I'm not sure. I think the monography might be losing its centrality a little bit, just because of all these other ways of getting information out there. Also, I mean, this is getting a little bit away from ethics, but the lines of what a researcher is and what you do as a researcher are, in a lot of cases, just crumbling. I mean, and we've seen it from what we've been doing together this week, and the energy stuff, and I mean, I am constantly more and more sure that the stuff going on with the energy is more dependent on getting people on board to understand and want to accept that stuff, then getting some little extra percent efficiency out of a solar cell. That's not going to be, I mean, we know what that is going to look like pretty well in the future, and we've known it, well, in some form for almost 200 years now, but, you know, in a good, solid technical form for 60 years. That's not going to change anymore. We got to get the people on board. And so, you know, what is research, right? Is it generating the information? I guess that's what I said before, but then that immediately is affected by this dissemination of information and what happens. So where is your role as a researcher? It doesn't seem, maybe I have to contradict Einstein a little bit. Maybe then we don't have to, but we may legitimately go outside of that role and, you know, generate some knowledge, but also choose to carry that knowledge to other people to try to inform them or to engage with them. I mean, really, and I really think that's important to listen when you're engaging in science communication, because the person you're talking to is not a technical expert. We'll let you know whether you're doing your job well or not. In terms of communication, they will let you know that. At the very least, they will lose interest in what you're talking about. And then you weren't doing your job very well. So, good.
Maybe a little point also. Einstein was famously contradicted by quantum physics. It's okay. There is a good company there.
That's the great thing about science, isn't it? It's probably one of the rare disciplines that you can work in where if somebody proves you wrong, that's okay. That's a whole new area to explore.
That's true.
But look at that guy. I mean, look at Einstein. Like, look at how he looked. I mean, he was sort of he had this ability to appeal to non-scientists as well. I mean, that's also, and a lot of the characters back in the, you know, a lot of the famous scientists had some kind of flair. So they had this human side, bit quirky maybe.
Maybe one point I could also say about science communication, sort of jumping from what Ben has just said, is that what these multimedia revolution is giving us is something that also has been discussed recently, is a different way of dealing with time. We sometimes call it different kind of temporality in scientific research. And that is, this time scale is really important because publishing a book takes how many? 3, 5, sometimes 10 years, depending on what kind of book that is, or at least a few years. And this different pace of research is developing in the natural and social sciences. It's already quite obvious that you cannot wait 3 years before you publish your research. It's just completely it's completely impossible. In humanities, it's a bit different, but yet this temporality of developing scientific ideas guides you also to consider different formats and reforms in how research practices need to take account of that temporality.
Sadly, speaking of temporality and time, our half an hour together has flown by. I love that we have started looking at centuries of the history of science and science communication, and we have now come to the question, what is research and what is a researcher? I think we're going to have to do all of this all over again and try and tackle those questions. But for now, thank you, Ben. Thank you, Maria. This has been brilliant.
Yeah,
Very much.